Final drives, which are commonly used on bulldozers and excavators, are the last component in the drive system that transfers power from the transmission or hydraulic system to maximize torque based on load. The final drive does this primarily through a planetary gear set by multiplying torque and reducing speed. The planetary gear set primarily consists of four components: the planets, the planet carrier, the sun gear, and the ring gear. Each of these components can be held with a set of clutch packs, with a fixed ring gear providing the highest amount of torque, a fixed carrier providing a torque reduction in a reverse direction, a fixed sun gear providing a moderate amount of torque, and a direct drive providing the least amount of torque. To protect the planetary gear set and other components in the final drive, we use a component called the duocone seal to retain the oil and keep contaminants out. The duocone seal uses a set of two metal sealing surfaces that seal against each other to be able to rotate with the drive. A large rubber O-ring called a torque ring applies pressure to the metal surfaces by using the resistance of the oil to keep the two surfaces together. The torque ring is designed so oil pressure pushes against the seal to create a better seal with higher pressure. Both the seal ring and torque ring sit inside the seal ring housing. Built into that housing is a small ramp that controls how much the seal compresses under load, with the retaining lip locking the whole assembly into place. Now that we've discussed these two important components, we can now start taking a look at the rest of the components during our assembly procedure. Before we start, this procedure requires cleanliness and precaution before assembling. All parts need to be cleaned with brake clean or alcohol prior to prevent excessive wear on components, as dirt and debris from improper handling can result in premature failure. The first component we are going to install is our tapered roller bearing. The tapered roller bearing needs to be installed using a bearing heater, since we need heat to expand the bearing to fit and be installed onto the shaft without forcing it. To use the bearing heater, we first need to put the probe on the inner ring of the bearing. The probe helps keep track of the temperature, as we need to heat the bearing to 135 degrees Celsius. The machine also demagnetizes the bearing to prevent metal particles sticking to it, which may also cause premature failure. We use a marker to mark a point of reference on the bearing to indicate signs of wear, as scoring may appear with use. Once the bearing is installed, we need to clean any oil from the duocone seal seat. We then need to install the torque ring onto the seal ring. Apply a thin film of clean oil around the seal ring. This helps the torque ring go on easier. Make sure to install the torque ring without rolling it on, as this may cause twisting, resulting in the ring coming out of its seat and wearing prematurely, as the drive will leak oil to open air and allow contamination to enter the drive. Place the seal in a special seal installer. You want to press the seal in, which prevents it from twisting as you install it into the seat. Use a can of brake clean to help lubricate and clean the surface as you press the torque ring in. You want to avoid using oil to lubricate during this process, as oil can push the seal out of its seat as it compresses. Once the duocone seal is installed, use the depth indicator on a vernier caliper and measure it in 3 spots 120 degrees apart from each other. Compare these measurements to the OEM spec, as being out of spec won't allow the seal to align and load right, resulting in premature failure. Our next component, the ring gear, needs to be hoisted using 3 bolts long enough to fit across the openings, as we need to be able to remove the cable once installed. Our next component, the retainer plate, which helps keep preload on bearings, needs to have its thickness measured with a vernier caliper. The thickness needs to be measured in 3 sections 120 degrees apart from each other. You can find the average by adding them up and dividing by 3. Now install the retainer plate onto the ring gear without any shims. Screw the plate in with 3 bolts 120 degrees apart from each other to clamp evenly. Each of these bolts have to be torqued down to 85 foot-pounds. Once these bolts are torqued, rotate the drive 360 degrees. Now measure the depth from the retainer plate to the ring gear. Record these new measurements and average them. Subtract them from the old measurements. Your final number is the thickness of shims that you need, in millimeters. Loosen and remove the 3 bolts that are holding the retainer plate in. You are now going to be adding the correct amount of shims that you need. Reinstall the retainer plate with all the bolts this time. Torque all of the bolts to 90 foot-pounds with a 120-degree torque turn. For our last step, we will be installing our planetary gear set. Install 3 eye bolts equally from each other and lift using the crane. Rotate until the planetary gear set meshes with the ring gear. Bolt down the housing using a breaker bar until all the bolts are snug. Install the cover that sits over the planetary gear set.